This is the review for Unit 6, Rational Exponents and Radicals. If you feel like you understand most of this pretty good, you might just want to go ahead and try the review and then look at the video for the parts that you're not doing well. But if you're struggling, you might just go ahead and work along with me, and then you can come back and finish the rest. Number 1, let's look at number 1. I have the square root of 245p cubed. There's two ways you can go about working these problems. You can do the tree method. And so if you have 245, you can say, well, I know that I can divide that by 5. And when I use my calculator, I say 245 divided by 5, and I get 49. Well, I got pretty lucky because 49 happens to be a perfect square, 7 times 7. So if you have 2 of something, square root is an understood index of 2. If you have 2 of something, you can pull that out. The number that you have left, that is going to remain under your radical. So in your answer, you're going to have a 7 out front, and then under your radical, index of 2, I don't write that, I'm going to have a 5. Now I have p cubed, p to the 3rd power. That means I have p times p times p. I have 2 of them, so I could pull one out, and then the other one is going to remain in the radical. The other way you can look at doing it is the way that I taught most of my students, is I look and I say, okay, what is the largest perfect square that I have in 245? Well, we learned here that it was 7 squared. We know that it's not divisible by 25, 5 squared, because it would have to be 250. It has to be an odd number. Could be 9, but if we tried that, it's not going to work out. We know that 7 squared equals 49. This 7 is going to come outside. I divide 245, the number that was under my radical, by 49, and I get 5, which is what goes under the radical. So we've got that and that. And we can do the same thing with our variable, p to the 3rd power. Divide that by the index, which is 2 for square root. 2 goes into 3 one time, and you have a remainder of 1. What these numbers mean is if I have p to the 1st power, I pull that out. I don't have to write the 1st power. And then my remainder is also a p to the 1st power. That stays under the radical. So I get the same answer either way. You try number 2 on your own, but remember that that is a cubed root. Your index is 3. So let's look at number 3. Write each expression in exponential form. So our index, we're going to write this radical. Whatever is under the radical, that is going to be what we put in the parentheses. So when you have a multiple choice test, don't forget to look for that 5p. Don't pick anything else. So now I'm going to write it in an exponent, a fractional exponent. This number right here, my index, that is going to go on the bottom of my fraction. Whatever power that all this is 2, we don't have 1, so it's understood to be 1. That's what comes on top. So I look at my answer choices, and I see that it is D. Oh, we forgot to check our answer choice on number 1. That would be C. So number 5, now we're going to write the expression that's in exponential form in radical form. So I'm just going to go the opposite way. Whatever's in the parentheses, that is going to go under the radical. So make wise choices in your multiple choice. This number, that is your index. It goes right here. And this is the power, the exponent that it's going to go to. So we're going to put that number right here. And so I look and I find out which one is that. First of all, I only want 4x. Hey, I'm able to get rid of everything else, and it is E. Number 7, we're going to have several simplifies. There's a couple more on the back of the page. I'm going to work this one. So let's remember some of our rules. If you have variables, here, you can't see what I'm writing, variables, and you multiply your variables together, what you're going to do to your exponents is you're going to add those exponents. If you are dividing, say you have a fraction, you're going to subtract your exponents. And then if you're going to raise an exponent to a power, you're going to multiply your exponents. So let's try this example right here. I have 2m cubed times n squared times m cubed times n to the -4th. Anytime you see a negative exponent, that, remember that you have to move it and change the exponent. This -4th only applies to the variable that it's connected with. So let's go ahead and rewrite this. I have 2m cubed n squared times m cubed. I'm going to move this to the bottom, and then my exponent changes to a positive. Now let's simplify what's on top of my fraction. I don't have anything to multiply the 2 with, so that's going to remain just like that. I have m to the 3rd power times m to the 3rd power. Both of these variables, my bases are the same, so I have to add my exponents. They're multiplied over here, so I add the exponents. And so I say m, 3 plus 3 is 6. And then I'm left with the n squared. And on the bottom, I have an n to the 4th. So now I can simplify it one more step. I have n on top and an n on the bottom. Whenever you divide, remember the fraction line means divide, you're going to subtract your exponents. There, subtract. I look and say, is my exponent larger on top or bottom? Wherever the exponent's the largest, your variable stays there. So let's rewrite this. I have 2m to the 6th power. My exponent is larger on the bottom than on the top. So I'm gonna have an n on the bottom, but not on the top. Now I'm going to subtract my exponents. 4 minus 2 is 2. So that is your answer. And you look over here, do I have that option? Yes, C. So when you turn the page and look at the top two, numbers 8 and 9, we're still simplifying. And so remember, this is a power to a power. What do? And then you have this fraction here. Oh, and you might look at this x to the 0 power. What is anything to the 0 power? It's 1. So let's look down to number 10. We're going to solve the equation, and we need to remember to check for extraneous solutions when applicable. I have 3 equals square root of 2p plus 1. This is isolated. You need to make sure, check to find out if your radical and or parentheses, is it isolated? If not, you need to isolate it first. It is. So since my index is understood to be 2, I'm going to raise both sides to the 2nd power. 3 squared, 3 times 3 is 9. And then whatever was under the radical, I just write that down. I got rid of the radical. That was the purpose of squaring it. And now it's just an algebra 1 problem, and I solve for p. First thing I need to do is try to get p by itself. I subtract 1 from both sides. 8 equals 2p. This means multiply. Inverse of multiplication is division. And I have p equals 4. And that is my answer. Now what if, number 12, I have n on both sides? So again, this is isolated, so I can go ahead and square it. But if I square this side, I have to square this side. And so I'm going to write what was underneath my radical, negative 21 plus 10n, and then I'm going to have n squared. I need a, I'm going to have a trinomial. I'm going to set everything to 0. So that means I need to move this 21 over to this side and subtract the 10n so I can move that over also. And I'm going to have 0 equals n squared minus 10n plus 21. I want to put them in order. N squared, then the n, and then my number. And if you want to, you can go back to your radical and make sure you have the opposite sign since you switch sides of the equation. So now I'm going to have to factor. I need to get it into in two sets of parentheses. This is a positive. So the only way you can get a positive is either you have a positive times a positive or a negative and a negative. Since this is negative, my middle term, these both will have to be negative. So I need to find, since this is 1, my A is 1, I need to find factors of 21 that when I add them, I get 10. They are going to be negative here, but I'm basically going to be adding them. So what are some factors of 21? Well, I know how I have 1 and 21. When I add those, I get 22. That's not 10. 21 is not divisible by 2. How about 3? 3 times 7 is 21, and when you add them together, you get 10. Bingo. We're going to put 3 and 7 here. So my solution set will be 3 and 7. Remember, we want each of these to equal 0. So 3 minus 3 is 0, 7 minus 7 is 0. So I need to check for extraneous solutions. These are both positive. What I'm basically looking for is in my original equation, I can't have this n be a negative number. The square root of something cannot equal a negative number. They're both positive, and so I'm going to select E. Let's look at 14. I have b to the 3/2 power equals 729. Well, let's just rewrite that. B to, because it's kind of messy and busy right there. To get, since this is isolated, to get rid of or undo this fractional exponent, I have to raise it to the inverse, the reciprocal. I flip this fraction around and raise it to the 2/3. These will cancel, but if I do this to one side, I have to do it to the other side. So B is going to equal to whatever this is. Now you can do it by hand. Remember, this is our index. I could say the cube root of 729, find that answer, and then square it. That's my power. Or you can put it in the calculator. You can input 729, hit that little arrow caret key, and then you're going to put 2 divided by 3, and it will give you the answer. And that will be 81. Because the cube root of 729 is actually 9. I had to use a calculator to figure that out, and then 9 squared is 81. So my answer is D. Okay, now we're on the last part of the review, the graphs. Square root and cubic root graphs. So remember our parent graphs. Let me get this where you can see it. If you have the square root of something, your graph is going to be the crooked finger. It's just going to be like that. And the cubic root, you're going to have the, like Miss Bailey says, a disco dude on its side, laying on its side. So let's do this one. This one's just a little bit more complicated, but not too bad. What's tricky is I have this 3 plus in front. And so that is really throwing everybody off. We had a problem like that in our practice problems. Your A, what gives you the reflection and stretch and compression is multiplied by this. This is actually added. So if we rewrote this, moved that in the back and said y equals the cube root of x minus 1 plus 3. That's the same equation. I'm not crossing the equal sign, so it's going to stay the same. You could graph that. So we know that it's going to be a cubic root graph. And we also know that it's going to go right 1, up 3. Or if you had, I don't know if you call it a vertex, but this is the middle part of our graph is going to be at 1, 3. So I'm going to look for that point. Which one of these graphs is at 1, 3? So right 1, up 3. This actually is it. I think it's A, but let's make sure the others aren't it. Well, this is a square root graph. That can't be it. This is at 1, -3, so that's not it. This is at 0, nope, -1, -3. That's not it. And then this is at -1, +3. So it would be A. We were correct. So on the back, the last 2 questions that we're going to work, let's look at 18. 18 and 19, they're asking for domain and range. So remember, the domain and range of cubic root is always going to be all real numbers. Okay, the trickier part is the square root. We need to look again at our starting point for our square root graph. And this is a +5, and so that's going to be a -5, and then -2. So that means this is my domain starting point, and this is my range starting point. So all my x's are going to be greater than or equal to -5, and all my y's are going to be greater than or equal to -2. This is reversed, so that's not it. It's not going to be all real numbers. Hey, -5, -2. That's it. We could look and make sure that these aren't right, but C is our answer. And then the very last 2 questions, you have to sketch the graph. That is correct. So let's do number 20, the square root. Negative. Remember, it's going to reflect if I have a negative in the front. So you might just say, okay, square root, I know that it's going to go like that, except for I have the negative, so it's going to reflect over the x-axis, and so it's going to look more like that. So let's find out where that starting point is. That is going to be, I changed the sign, -2 and then -2. So I'm going to go left 2 and down 2. And then remember, instead of going like this, I had the reflection, the negative, and so I'm gonna kind of draw it badly. It's gonna go something like that. Now, if you look down here, this is a rubric of how your teacher will be grading your graphs. You're gonna get 1 point for the correct parent function. So did you do, for square root, did you go like that? Or for cube root, did you go like that? So did you get the basic shape correct? Did you do the horizontal shift right? Did you go right or left correctly? Did you get the vertical shift right? Did you go up or down correctly? And then did you get the reflection and or stretch or compression correct? So we're not going to look to see if it's exactly drawn right, but those points need to be correct. Good luck, and I hope this helped. See you later.